We all know that feeling, right? That spinning wheel of death, that frozen loading bar. It is just the worst. But what if there was a secret? A really elegant idea that makes our entire digital world feel instantaneous? Well, that's what we're going to dive into right now. Let's get to it. You know the drill. You click a button and you wait. You stare at that little circle going round and round. That frustrating pause, that feeling of being blocked, is the exact problem we're here to talk about. And it's the very thing that asynchronous systems were invented to destroy, making everything feel faster and way more responsive.
So, how do we solve this whole waiting game? Well, the answer, believe it or not, doesn't come from some high-tech lab in Silicon Valley. It actually comes from a steakhouse in San Jose, California. Yeah, they figured out this absolutely genius system to serve tons of people super efficiently. And it turns out, it's the perfect way to understand how our computers can do the exact same thing.
Okay, so picture a totally normal restaurant experience. Everything has to happen one step at a time in a very specific order. You can't order your food until you're seated. The chef can't start cooking until you've ordered. Every single step blocks the next one. It creates this long chain of just waiting. That's what we call a synchronous process, and it's just filled with wasted time. Now check out how this steakhouse, Henry's High Life, completely flips the script. You get a menu the second you walk in the door, you go order at the bar while you're waiting for your table, and your order goes straight to the kitchen. So the two long tasks, waiting for a table and cooking your food, they happen at the same time. See? This is the core idea of asynchrony. If you don't have to wait, don't.
So that's how it works in the real world. But how do computers actually pull this off? Well, it really comes down to two totally different styles for handling tasks. You can think of it as the difference between a really demanding boss and a super polite colleague.
On one side, you have preemptive multitasking. The operating system is the boss. It is in total control. It can interrupt any task whenever it wants to let another one have a turn. But on the other side, you've got cooperative multitasking. This is our polite colleague. In this model, each task runs until it hits a natural stopping point and then voluntarily passes the baton to the next task.
This quote right here, it perfectly captures the whole idea of cooperative multitasking. It's like the task itself is smart enough to say, hey, I'm about to do something that's going to take a while, like wait for the network. So I'll just step aside for a bit. You guys carry on. But that brings up a really important question. How does a task just politely step aside? Well, the magic ingredient that makes this whole cooperative thing work is a special kind of function that has a superpower. It can actually pause itself. And these magical functions are called coroutines. A coroutine is a total game changer. You see, a normal function has to run all the way to the end, no matter what. But a coroutine can get to a certain point and say, you know what, this is a good place to take a break. It hits pause and yields control. The program can go off and do a bunch of other useful stuff, and then, when it's ready, it comes back and the coroutine picks up exactly where it left off. It's the technical version of that polite colleague. Okay, so we have these functions that can pause themselves, which is cool. But wait a minute. If a function pauses before it's done, how do we get the final answer from it? How do you get a result without just, waiting around? This is where an object called a future comes into play. And you can really just think of it as a promise. When you run one of these asynchronous functions, it doesn't immediately give you the result. Instead, it instantly hands you back this future object, which is basically a promise that says, I will get you that result, just, later.
The absolute best way to think about this is ordering at a super busy fast food joint. You place your order, and what does the cashier give you? A receipt with a number on it. That receipt is your future object. You don't just stand there blocking the entire line, right? No. You go find a table, you check your phone, you do other things. Then, when your number gets called, you trade that receipt, your future, for the actual burger, which is the final result. You got to be productive instead of just standing there waiting.
All right, time to put all the pieces together. We've got our coroutines, the functions that can pause, and we've got our futures, the promises for a result. Let's see how they combine to build a ridiculously efficient system. We're going to design a server for a pizza joint that never ever gets stuck.
So in your standard old-school synchronous pizza server, cooking a pizza is a long, blocking task. It takes, 10 minutes? So while that one pizza is in the oven, the server literally can't do anything else. It can't take any new orders. The phone can be ringing off the hook, but nobody's answering because the whole system is just frozen, waiting on that oven. And just look at the difference in performance here. It's staggering. The synchronous server spends almost all of its time doing absolutely nothing,
just waiting. But the asynchronous server, it slashes that waiting time. It is almost always doing something useful.
So what's the secret? How does the async server do it? It uses something called an event loop as its front counter. Think of it like a super fast cashier that only does one thing: take new orders. As soon as a long job comes in, like cook_pizza, the event loop just hands it off to the kitchen, a background worker, and immediately turns to the next customer in line. It never, ever blocks. So it can handle a massive number of orders without even breaking a sweat.
So let's wrap this all up. Why is it so important to understand all this? What is the big takeaway? When should you actually use this kind of approach? An asynchronous model really shines when you're dealing with a huge number of tasks, especially when those tasks spend most of their time just waiting for stuff, like waiting for a network response or waiting for a database to get back to them. And that makes it the absolute perfect tool for building the busy web servers that power the entire internet and for creating those snappy, responsive apps that we all love to use. And here's the truly mind-blowing part: the efficiency. For a computer, creating a new operating system thread is a pretty heavy, expensive operation. But creating one of those coroutines we talked about, it's incredibly cheap. It's practically free. So with this cooperative model, a single expensive OS thread can easily manage thousands, sometimes even millions of these super lightweight coroutine tasks. The ability to scale is just off the charts.
So the next time you're scrolling through your social feed and new posts are loading in seamlessly, or you're playing a game that's downloading an update in the background without a single stutter, you'll know the secret. It's not magic. It's just a really elegant asynchronous system working tirelessly behind the scenes to make sure you never have to wait. Thanks for tuning in.